This is Radio Direction Finding, Analog and Digital Applications for HamSCI 2020 by Cadet Nolan Pearce, KE8JCT. My poster introduces the concept of radio direction finding and discusses both its analog and digital aspects. So what is direction finding? It is a hobby activity just like moonbounds or QRP, occurring primarily in the VHF band. In scheduled events called fox hunts, one ham will transmit on an agreed frequency from an unknown location. Other hunters use RDF tactics to find the location of the signal. First and probably easiest is analog direction finding. Analog hunters use only directional antennas like beams or Yagis and rotate their antennas to hear the signal gain and lower in volume. So for example, here's a Cadet Amateur Radio Club W2KGY in the middle left picture. And we're armed with our PVC tape measure antennas, so they were incredibly cheap and homebrew. Below is an antenna gain plot on EasyNet for a 3-element 2-meter antenna. And when we direction find, we're keeping this gain plot in mind. So when we're at 0 degrees to the signal, we hear a peak. And then as we rotate 90 degrees, we'll hear a null. So we won't hear the signal well at all. 180 degrees, we're going to hear it slightly better. And so we will physically rotate our bodies until we hear the signal in the strongest strength. And then we assume that to be 0 degrees, and then we continue from there. So DFers also attenuate their signals by removing antenna elements, for example, to have increased selectivity on their signal. So in our fox hunt, all we would do was take an element off of our PVC antenna, and then we'd have greater selectivity over our signal, so we'd be able to hear the peaks and nulls much clearer. So the equipment is very low cost, and it's usually homebrew with analog direction finding. So it's very responsive, but only gives bearing signals, nothing like the GPS location of digital direction finding. Digital direction finding produces a higher yield of information at a greater cost of knowledge with signals. With software to find radios, you can get GPS coordinates of your signal. Further, many software programs like MATLAB and GNU Radio allow for the identification, retransmission, and demodulation of captured signals. So here's an AM signal demodulation in MATLAB. In the blue and in the light orange is an AM signal, so that's coarse amplitude modulation. It has a carrier frequency and then a message frequency. So in MATLAB I was able to capture an AM signal and then demodulate it to just the orange signal, which is my message frequency, which is a sinusoid. And that could be speech, or that could be a digital transmission also. Digital direction finding and signal intelligence is an ever-increasing industry, but sometimes cannot be beaten by its immediate response analog counterpart. So here's a Pearce SDR at the image below. The Pearce SDR is 4 RTL SDR dongles that are clocked synchronously, allowing for a direction finding array. And it is $150, but you are able to get GPS coordinates from a signal that you transmit, which is really impressive on a VHF band. And this is from its Android app, which is it gives you a compass bearing of your signal. So the equipment is usually high-cost SDRs. So the Pearce SDR, the Hacker F1 is used more for signal identification, but it used a lot in demodulation. And then digital signal processing software, so like MATLAB or GNU Radio. So you can do all sorts of cool things with digital direction finding. It gives a bearing, a GPS location, and the ability to decode and manipulate signals within the SDR software. So you can do all these things requires a lot of knowledge on your software and a lot of knowledge on your signal. And if you're trying for the same result of just direction finding a signal, maybe your analog direction finding would be better because maybe you only need a bearing and not a GPS location. So I hope to explain both the differences in the analog and digital aspects of radio direction finding. Thank you.